Number 13 on the test review says solve log of 9x squared minus 24 plus log of 1/3 equals log of 2x. So we're solving that for x. The first thing you want to do is combine these two logs on the left into one log. Remember, you can do that because the bases are the same. They're both base 10. And that plus sign is going to become multiplication. So 9x squared minus 24 times 1/3. So 1/3 times 9x squared. Thank you. 9x squared times 1/3 is 3x squared. Negative 24 times 1/3 is negative 8. So I just multiplied those together. 9x squared minus 24 times 1/3. And that's going to equal log 2x. At this point, we want to get rid of those logarithms. And you want to realize that these are the common log, which means the base of both of these is base 10. So we're going to want to raise these both to the 10 to the power of these things. So 10 to the power of log 3x squared minus 8 equals 10 to the power of log 2x. These 10s are going to cancel out. The 10 and the log will cancel out on both sides, leaving us with 3x squared minus 8 equals 2x. And this is a quadratic that we need to solve. And to solve a quadratic, we need to have a 0 on both sides of the equation. So I'm going to subtract 2x from both sides to get 3x squared minus 2x minus 8 equals 0. And there's a bunch of different ways you can solve this. You can use the quadratic formula. You can graph it, see where it crosses the x-axis. But I prefer to factor. So I'm going to factor this thing. And since the number in front of the x squared is greater than 1, I'm going to use the box method. And inside the box, I'm going to write that 3x squared and the negative 8. And 3 times negative 8, well, that's negative 24. So I'm thinking of two numbers that multiply to negative 24, but add to negative 2. Two numbers that multiply to negative 24, but add to negative 2, well, that'd be negative 6. X and positive 4x. And then I'm looking for the greatest common factor, but here the greatest common factor between 3x squared and 4x is just x. Negative 6x and negative 8 is negative 2. 3 and negative 6x is 3x. And then 4 and negative 8, that's a positive 4. So when you factor this thing, you've got 3x plus 4 times x minus 2 equals 0. When you set these both equal to 0, well, you've got x equals, let's see, negative 4 divided by 3 is negative 4/3, and positive 2. Now you've got to check for extraneous solutions just in case there are any. In this case there are, because if you look at the right-hand side of this equation here, that says log of 2x. Well, 2 times negative 4/3 is negative 8/3. Remember, you cannot take the logarithm of a negative number. So that first solution, that's extraneous. There's only one solution here. It's x equals 2. And that's number 13. Probably the hardest one on there. Number 16 is what we're doing next. Another solving one. Slightly easier because it's exponentials, and I think exponentials are always easier than logarithms. To solve an exponential, we're usually going to take the log of both sides, but before we can do that, we've got to subtract that 1, divide by 3. So I'm going to subtract by 1 first to give me 3 times 2 to 0.5x power equals 1.375 minus 1 is 0.375. And then we're going to divide both sides by 3 to get 2 to the power of 0.5x equals 0.125. And at this point, this is where we're going to want to take the log of both sides to get rid of this exponent. So we want to bring that exponent up front to get 0.5x times the log of 2 equals the log of 0.125. So we're trying to get that x by itself, so we're going to divide by the log of 2 on both sides. We're going to have 0.5x equals log 0.125 divided by log 2. And then we're going to need to take all of that, whatever this ends up being in the calculator, and divide that by 0.5 or multiply by 2. It's the same thing. So x is the log of 0.125 divided by log of 2. And then I need to divide that by 0.5. And when you type that in the calculator, let's see what it is here. Log 0.25 divided by log 2. And we need to divide all of that by 0.5. I got x equals -6. Exactly. -6. Now we can plug that back in, you'll see it's right, but we really don't need to check for an extraneous solution here because those extraneous solutions only happen when we're dealing with quadratics usually, or something to the 4th power to the 6th power. So I'm pretty confident that x equals -6 is the correct answer. That's number 16. The next one I'd like to do is number 19, which is just writing a bunch of formulas. So we're supposed to write an equation modeling each of the following situations. $20,000 is invested in an account which accrues 1.65% interest compounded annually for t years. So we usually start with an A for the future value, equals the present value, which is P, times 1 plus the interest rate divided by 100 is 0.0165 divided by the number of compound periods per year, which in this case it says annually, so that's just 1, raised to the 1 times t power. You got to repeat that 1 twice. So you didn't really need to write that 1 there. You could have done it without the 1, and it would have been the same thing. I'm just plugging it into the formula that you'll have for the test. So you don't need to memorize that formula, but you need to know how to use it. The next one is $5,000 is invested in an account which accrues 2.1% interest compounded quarterly for t years. So quarterly means 4 times per year. A equals 5,000 times 1 plus the interest rate divided by 100, so that's 0.021, divided by the number of compound periods per year, which is quarterly, so 4 times per year, raised to the 4t power. Number of compound periods times t. Part C, $6,500 is invested in an account which accrues 5% interest compounded daily for t years. So A equals 6,500 times 1 plus 0.05. So daily, that'd be 365 times per year, raised to 365 times t power. Write the equations. Number D, letter D, last one we're going to talk about, is 1,000 invested in an account which accrues 1.25% interest compounded continuously. So remember, compounded continuously is slightly different equation. P times e to the RT power. So A equals the amount we start with, that 1,000, times E, which stands for like 2.718, da-da-da-da-da. There's a special button on your calculator for that, second natural log, to the power of 0.0125 times t. And that's all of 19. In 20, the next one I'm going to do, we actually need to do some calculations with that, so I'll show you how to do it in the calculator. So 20, we've got $10,000, and it's invested at 4.5% interest. Find the value of the principal after 8 years given the following compounding periods. So how much is that $10,000 worth if it's compounded once per year, so annually? So figure that out. It's going to be A equals that 10,000 times 1 plus 0.045 divided by 1 raised to the 1 times 8 power. So I'm going to show you how to type that in your calculator. We've got that 10,000 there. Oops. 10,000 times 1 plus 0.045 divided by 1. Raise it all to the 1 times 8 power. Now I'm typing in those ones even though I don't need to because I'm going to call this up in a second here just to change that 1 to a different number. When I hit enter there, I've got $14,221.01. And that's for part A. Now, if it's compounded weekly, we're just going to modify the equation slightly. Instead of doing ones in there, we're going to divide by how many weeks there are in the year, which is 52. I'm going to raise it to the 52 times 8 power. So when I retype all that in my calculator, I'm changing those ones into 52s. And just compounding it slightly differently. Close the parentheses. Increases our money to $14,331.06. I don't think you can see that very well. When we do it monthly, it's the exact same formula, except instead of 52s, we're doing 12s. And that small modification, changing 52s into 12s, gives us a little bit less money. That's $14,323.64. Compounded continuously, that's going to be different typing it into the calculator, because that's A times the 10,000 e to the 0.045 times 8. So when I type that in the calculator, 10,000 times e to the 0.045 times 8, like that, gives me a little bit more money. I've got $14,333. This is why you want your money to be compounded continuously, because you end up with a little bit more when you do that. So you end up with $14,333.29. So that's number 20. And I think I have just enough time to do number 24. So that's the last one I'm going to do here. '24 says a coroner uses a formula derived from Newton's law of cooling, a general cooling principle, to calculate the elapsed time since the person has died. There's a formula there, where the T stands for the measured temperature of the body, and the R stands for the room temperature, which we assume to be constant. A coroner measures the temperature of the dead body at 6 a.m. and records the temperature to be 82 degrees. The body's been in a room for 68, in a room which is 68 degrees Fahrenheit. What's the time of death? So we're just going to plug the information we know directly into the formula. T equals -10 natural log of the temperature, which is 82, minus the room temperature, which is 68, divided by 98.6, which is your temperature when you're alive, minus 68. And this is just calculator work, so we're going to plug this directly into the calculator to get -10 natural log of 82 minus 68 divided by 98.6 minus 68. This person died 7.81, let's call it 7.82 hours ago. And to make that into minutes, you take that 0.82 and you multiply it by 60. So that's going to be 7 hours and 49 minutes. So what time is it? 7 hours and 49 minutes before 6 a.m.? Well, that's the previous day. The time of death would be at 10:11 p.m. the previous day. That'd be 7 hours and 49 minutes before 6 a.m.